Today we're going to start a new chapter in physics. We're going to talk about kinematics. Kinematics is the study of motion. There are different types of motion like linear motion, projectile motion, circular motion, simple harmonic motion, oscillatory motion, rotation, and all sorts of other motions. And in our syllabus we have to study these types of motions, and circular motion and simple harmonic motion in A2. We're going to talk about linear motion and projectile motion in AS. We're going to start with linear motion. Linear motion is fairly simple and straightforward. It is a motion in a straight line, or you can say a motion in one dimension. Whenever there is motion involved, there are a few terms which you need to know about. For example, an object's position, its the distance it traveled, its displacement, its speed, its velocity, its acceleration. You may have used these terms in your daily life, or you may have studied them briefly. However, let's discuss about them here in detail. Let's start with distance and displacement. What are these terms and what is the difference between these two terms? Let's see. So distance is basically a total length of a path traveled by a moving object. It is the total distance or a total length of path that a moving object has covered. It is a scalar quantity. Displacement, on the other hand, is the change in position of an object. So displacement of an object is how far the object has traveled from its initial position. It does not measure the total length of path that an object covered. It is a vector quantity. Let's say an object starts from A and takes this path to reach B. So the distance traveled by the object is the total length of this path, but displacement is the straight distance. So displacement is basically the shortest distance between the 2 points, and distance is the total length of path that the moving object traveled. So let's clarify this concept with an example. Let's say there is a guy who is traveling from his home to a mall. So this is a mall for shopping. The total distance between his home and the shopping mall is, let's say, 100 meters. So the boy starts moving towards the shopping mall. So after he has traveled, let's say, 80 meters, he realizes that he has dropped his wallet on his way. So he heads back towards his home to find his wallet, and he finds wallet at this point P, which is 40 meters back. So after finding his wallet, he then heads to the shopping mall, and after he finishes his shopping, he heads back home. In this scenario, let's consider his motion up to point P. So up to point P, the boy, he headed towards the shopping mall. For shopping mall 80 meters, then he returned back to the point P 40 meters. So the total distance the boy has traveled is 80 plus 40, which is 120 meters. But the displacement, if you consider the motion up to point P, the total displacement of the boy is only this distance, because his initial position was his home and his final position was the point P. To find displacement, all we have to do is to determine the initial position and final position, and the distance between these two positions is the displacement. So the displacement here is 80 minus 40, which is 40. Let's consider his motion. Until he returned home. So he headed towards the shopping mall 80 meters, then he came back 40 meters, and then he went to the shopping mall, and then he came back home. So the total distance he traveled was 80 plus 40 back, plus again 40 right to this point, plus this distance here is 20. So this is his total distance. He traveled 180 meters, and when he headed back he traveled 100 more, which would give me 280 meters. So the total distance the boy traveled was 280 meters, but the displacement of the boy here is, well, figure it out, it is 0 meters, because he started from his home. He went in all sorts of directions and traveled many different places, but he returned back to his home. So his initial starting point was home, and his final ending point was also home. So his displacement was 0 meters. Again, to find the displacement of an object, we consider its initial position and we consider its final position, and the distance between these two positions is the displacement. Since our displacement is a vector quantity and distance is a scalar quantity, displacement can be negative, but distance can never be negative. Let's see when the displacement can be negative. Let's say the boy then heads in this direction towards his friend's house. It's a 40 meters, and he stays at his friend's house. So the total distance he traveled will be plus 40, and the displacement he had here would be minus 40, because his initial position was this and his final position was this, and we are taking this direction as positive direction. Since we are taking this direction as positive direction, his displacement was in this direction, so his displacement is minus 40, negative of 40. So you can see that displacement can be negative as well, but distance can never be negative, because distance is a scalar quantity. Now let's talk about speed and velocity. Generally, these terms are simultaneously used to mean the same thing. Both of these terms are used to describe at what rate an object is moving. So both of these terms are used to describe the rate of the change of distance or displacement, but there is a slight difference between these two. So speed is rate of change of distance, so it is a scalar quantity, and velocity is the rate of change of displacement, and it is a vector quantity. So speed would be distance over time taken to travel the distance, and velocity would be displacement over time taken for that displacement. Velocity is denoted by v, displacement is denoted by s, and time taken is denoted by t. So v equals s by t. So this is a general formula to determine the velocity of an object. So whenever we use this formula, what we're actually talking about is the average velocity. So average velocity is like an average velocity for the duration of displacement. So this velocity, this value just gives at what rate on average the displacement of an object was changing. So let's clarify this point a little bit clearly. In our previous example, we had a guy who was heading towards the shopping mall to buy whatever he wanted, and his home was here. So the distance between his home and his shopping mall was 100 meters. So initially the boy starts from his home, and after he has traveled 80 meters, he then comes back and travels 40 meters, and then he goes to the shopping mall. Let's say he took 8 seconds to reach point P, and let's say he took maybe 6 seconds to reach point Q, and then let's say he took maybe 10 seconds to reach the shopping mall. If we consider his motion up to point P, his average velocity would be displacement over time taken. So the total displacement was 80 meters, and he took 8 seconds, 10 meters per second. The average velocity of the boy from point A to point P is 10 meters per second. So what this number really says that his average rate of change of displacement was 10 meters per second. Looking at this value, we cannot say for sure that whether he was running at some point, or maybe he was taking a break, taking a rest, maybe he was walking. So maybe his rate of change of displacement could vary between these points, right? But we do not know about that. We only know that his average velocity from point A to P is 10 meters per second. So that's why we call this average. So maybe when he started from his home, he may have started running very fast, and when he reached this point, he may have started walking slowly, and maybe when he reached this point, he took a break, like maybe 2 seconds, and then he ran to reach point P, right? He could have reached point P in any way. We do not know about that. What we know is he reached point P, which is 80 meters from point A, in 8 seconds. So we can find his average velocity to be 10 meters per second. Here average speed would be same distance. So distance over time taken, which would be again 10 meters per second. Here average speed and average velocity are same. Now let's consider his motion up to point Q. So his average velocity would be displacement over time taken. Average displacement from A to Q is 40 meters. So we already discussed about that. And he took 8 plus 6 seconds, which would give me 14 seconds. So his average velocity would be 2.86 meters per second. So this number here, it gives me an average velocity at which he traveled to reach point Q from point A, but it does not give us information how he reached point Q. We only know that he took 14 seconds to reach point Q from point A, and distance from point A to point Q is 40 meters. And here average speed will be different. Average speed will be distance over time taken. Total distance he has traveled will be 80 plus 40, which is 120 meters, and he took time of 14 seconds, 8.6 meters per second. As you can see that his average speed here is higher than its average velocity. Velocity is a vector quantity, so it has a direction. So here 10 meters per second to right, and here average velocity 2.86 meters per second to right to the right. If you consider the motion from A to the shopping mall, we find average velocity to be displacement over time taken. So the displacement is 100 meters from A to shopping mall, and he took 8 plus 6 plus 10, which is 24 seconds, 4.2 meters per second to right. And his average speed is distance over time taken. So the total distance he traveled while moving from A to shopping mall is 80 meters, then 40 meters back, and then from point Q to shopping mall, which is 60 meters. So the total distance he will travel will be 80 plus would be 80 plus 40 plus 60, right? And all divided by 24 seconds, which would give me 7.5 meters per second. So his average speed was higher than his average velocity. So this is the difference between the average velocity and average speed. The reason why I'm using the term average is because we do not know his instantaneous speed or instantaneous velocity. The instantaneous speed or instantaneous velocity is the real-time velocity. For example, his instantaneous velocity when he was running would be higher than his instantaneous velocity when he was walking. So to find instantaneous velocity and instantaneous speed, we use calculus. We use graphs for that, and we will be learning about graphs in our future videos. So that's where calculus comes in, to find instantaneous velocity, instantaneous speed. For now, what we can only find is his average velocity and average speed. So sometimes what students tend to think is that average speed is initial speed plus final speed divided by 2, but that is not actually the case. So let's see an example. For example, here is a point A and here is a point B. So let's say a boy travels from point A to B in a uniform motion at 40 meters per second. The distance between point A and B is, let's say, 100 meters. And when he heads back to point A, he comes at 60 meters per second. So what is the average speed for the duration of his motion? So students, what they tend to do is average speed equals 40 plus 60 by 2, and right answer 50, which is absolutely incorrect, because let's see, we know that average speed is total distance covered by an object over total time taken by an object. Here total distance would be 100 meters plus 100 meters, 200 meters. And I need to figure out the time that the boy took to reach point B and the time that he took to come back to point A. So to find the time T1 that he took to reach point B, for T1 we have distance equals 100 meters and his average speed, I'm gonna average speed as V, average speed was 40, and we know the formula V equals d by t, which would give me t equals d by v. So 10 by 40 would give me 1 by 4. So I'm going to put t1 equals 1 by 4. Similarly, t2 equals 100 by, sorry, it's not 10 by 4, it is 100 by 40, so it will give me 10 by 4. 100 by 60, which would give me 10 by 6. So 10 by 4 plus 10 by 6 is the total time that it took to return back to point A, and his average speed would be 48 meters per second. So his average speed for the duration of his travel was 48 meters per second, which is different than the answer that we got by using this incorrect formula. Now let's talk about acceleration. Acceleration is a rate of change of velocity. So it tells us at what rate the velocity of an object is changing. So acceleration is a vector quantity. And it can be written as A equals change in velocity over change in time, or the time taken for that change. Acceleration can be negative, can be positive, can be 0, and if acceleration is 0, it means that velocity is not changing. Let's say a boy, he starts from rest and he reaches his speed of 5 meters per second in let's say 2 seconds. So his acceleration here would be change in velocity, which is 5, and the time it took was 2, which is 2.5 meters per second squared. So this is acceleration. So acceleration can be written as b minus u by t. V is the final velocity, u is the initial velocity, and t is the time taken to reach final velocity from initial speed, initial velocity. So if we rearrange this formula, we get a famous equation: v equals u plus at. So v, the final velocity, is u is initial velocity plus a times t. Acceleration can be negative, and negative acceleration is known as deceleration. For example, let's say there's a hole and this boy now has to come to stop here because he cannot walk through the hole. So he will start controlling himself. Let's say he reaches from 5 meters per second to 0 meters per second in 1 second. So his acceleration will be v minus u by t is 0 minus 5 by 1, which will be minus 5 meters per second squared. Acceleration is negative of 5 meters per second squared, and his deceleration is 5 meters per second squared. So deceleration is negative acceleration or retardation. So this much for today, and we're going to explore further about speed, velocity, acceleration, distance, displacement in our next video.